Welcome to PennLive. I am your temporary announcer for the evening. My name is Scott Boyd. Tonight we're going to be seeing a talk on securing web applications in a LAMP environment by Mike Shima and Matt Burgess. We also have a good series of books that we will be giving away for review later. So welcome to PennLive. I also have this to pass around. If you're not on our mailing list, please sign up. Thanks.
Thanks. As Scott said, I'm Matt Burgess, and this is my accomplice, Mike Shima. And we're going to talk about securing web applications in the LAMP environment. This talk is primarily focused on just a quick overview of what LAMP is, or what we're going to consider LAMP tonight. We're going to look at some vulnerability exploits, how people take advantage of these applications. We'll talk about securing the environment as well. We won't get in so much the issues with securing Linux per se. We'll touch on a few things here and there, but for tonight we'll focus specifically on the different components of LAMP. So, if you're not familiar with LAMP, it's usually referred to as this application stack of Linux, Apache, MySQL, and PHP. The P could be Perl, it could be Python, it could also be Ruby or Smalltalk or whatever you want. It doesn't really matter. There's a whole bunch of different acronyms for the variety of these different stacks. But the idea is it's basically this open source collection of tools that drive a lot of web applications that are freely available. There are quite a bit that run on the platform, specifically the PHP platform. Things you're probably familiar with, like bulletin board software, PHPBB, vBulletin. vBulletin I don't believe is open source. WordPress is a pretty popular blog software that runs on this environment, as does Joomla and Twiki, some CMS applications. And I've personally seen it a lot in commercial web hosting environments, not maybe something like Rackable or something like that per se, or I can't remember the name, but a lot of the web hosting companies that are catering to the small to medium size customer. Generally the ones that run like cPanel or Plus control panels, it's all Linux, Apache, MySQL, and PHP. And another feature of these applications is they usually tend to be self-contained unless it's a really, really big application serving a lot of users. It's usually the web server is on the same box that the database server is on. And this can also lead to a lot of problems. So tonight we'll talk about vulnerabilities that affect web applications. I mean, the vulnerabilities we'll talk about will cover web applications in general, but we'll take advantage of some of them with respect to the environment that it's operating on. And we'll talk about a little bit about how the not securing the default configurations of some of the components can lead to some problems. As I said before, we won't go into detail on securing Linux per se, or securing, dealing with vulnerabilities in the underlying software, like a buffer overflow in Apache 2.0.52 or something like that. We won't talk about that. We'll go on to web application vulnerabilities then. And when I talk about web application vulnerabilities, I'm referring to problems that are in the code, the server-side code of the application, or the user space code of the application. That's what your browser is. That's the HTML, the JavaScript, all that stuff that's interpreted and displayed by the browser. In a lot of cases, these web application vulnerabilities are really a lot more dangerous than some of the problems that we'll see in server configuration later on. So we'll head into some of the demos now. We'll talk a little bit more about the web application security now.
So we're going to start off talking about cross-site scripting. Cross-site scripting is a problem in web applications that's not specific to PHP or a specific programming language. It takes advantage of HTML. And it's an attack where as an attacker supplies some bit of code or some type of payload that's going to rewrite the actual HTML markup of that page. So rather than presenting something that says welcome map or hello, welcome to the forums, you would change your first name, for example, instead of being Matt, it could be something else. It could be markup language, like script tags, pop up an alert window. Now, what's important to keep in mind is that, and what we're going to demonstrate tonight, is that a lot of times people talk about popping up to this alert window, and that's how you test for cross-site scripting. Well, that's an effective way of testing. It's a way to identify the vulnerability, but it sort of glosses over what the real impact is of these types of vulnerabilities. So what we're going to show are a couple different examples of cross-site scripting and how much of an impact they can really have on the web application. And then we're going to go through a couple other demos as well, some other vulnerabilities. And after that, we'll go through what you can do to attempt to secure your web server or your web application if you don't have access to the source code or if you don't have control over being able to change the source code. So Matt, let's go ahead and show off some hacks.
Okay. I should mention that if there's anything that you have a question about, feel free to ask as we go along. We're kind of glossing over a lot of stuff and assuming at least some understanding of HTTP and web applications in general. So if you have any questions, feel free to ask. So as Mike suggested with
let's go ahead and introduce the PHP site so that they can see what our victim is for the. Our victim for the evening is PHP New. We picked out an older version of it. This is basically to protect the guilty, because newer versions there are no published vulnerabilities for them. We also want to follow responsible disclosure and not throw out a bunch of vulnerabilities that you could go and do some Google searches on tonight and find some credit cards. For $50, then talk to us after the presentation.
Hold on a second. Our little networking escapade at the beginning of this seemed to have clobbered VMware's networking.
So what we'll be demonstrating, we have our PHP Nuke site, which if you're not familiar with it, it's basically a content management system. It can support forums as well as news. It's similar, for example, to Slashdot or any Slash-based site. So that's going to be our target. Then we're going to have a victim user, a normal user of the application. This user doesn't have any administrative privileges, doesn't have any special privileges to PHP Nuke. And then, of course, we have our Wily hacker. And our Wily hacker currently is getting his attack environment set up. But once that's done, we're going to demonstrate different ways of really exploiting the simple vulnerabilities that are in this web application and really showing how they can expose the information on the application, as well as giving us basically command shell access to the web server.
Or not. Bring the virtual machines down.
You can dance now.
In the meantime, if someone will pass the tutu forward, we'll have the dance portion of these. So I guess we'll do a little bit of the interactive portion of the evening. How many people are familiar with cross-site scripting or SQL injection, or have come across these terms and seen them? Okay, good, fair number. And is there a particular programming language of choice, or do we have web application programmers in here that use PHP or Perl? Is there a preference? PHP? Yeah, 2. Perl? Ruby? No Ruby? Nobody jumped on that? Anybody still doing CGIs and shell?
Okay.
Why?
There's one victim.
It worked.
Python. Yeah. Oh, sorry, Python. I left out the big one.
Your demo was some code that's executing on the laptop, but appearing to be a remote site.
Yeah.
Right. So we have a few different images that we're using. So with a single screen and a single laptop, it's not necessarily clear exactly what's going on. So we have our web server that can imagine that's hosted over on some ISP or in your basement, for example, on top of some cinder blocks. But this is your web server, and then the victim, the user that we're going to go after, this user could be somewhere else out on the internet, and we don't even have to know. We don't need to know their IP address. We don't need to know anything about them, except an email address, because we're going to try and do some social engineering attacks, some very simple attacks against this user. And then our attacker, of course, is going to be somewhere else on the internet. And all the communication that's going to be happening tonight between the victim and the web server and the attacker and the web server, it's all over port 80 or conceivably over port 443. So this is another one of the highlights that from a network level security, your port 80, port 443, they're always going to be open. And of course you can block Telnet, SSH, all these other protocols. But as you'll see imminently, that just blocking all of those doesn't necessarily prevent the web server from being compromised.
This is what the site will look like when it finally comes up. Another point, because we've only got the one laptop here, we have, did you mention both browsers? We've got two browsers going, and we'll switch back and forth between them. But this one kind of looks like Safari, just to make it look different. It's going to be the attacker's web browser, and then this one looks like plain old Firefox default theme, and that'll be our victim's browser for the purpose of the demonstrations.
What are you trying to say?
The Firefox is good at handling skins. What else would we say?
Both of the virtual machines have to be shut down. You want to guess what the load average on the laptop is?
Do you have anything to give away?
No, I suppose. I have to turn both of them on.
Yeah.
And I was gonna heckle you, maybe it's way too easy, guys.
Aim to please.
I don't think they used network.
Well, but besides these attacks are also, I was reading about, there's a botnet creation systems out there now. Basically, they compromise one server on a website. They use that to push their compromised code out to any browser that clicks on the link on a compromised server. So this would be the starting point for a botnet exploit too.
Yeah, pretty much. So one of the scenarios we'll show off is that you can use one of the drawbacks of browsing the internet is that there's an assumption of trust against the site you're going to. And what you're allowing that site to do is execute anything it wants inside your browser. So for example, when you go to Google or CNN or Yahoo or any of these places, you have an assumption that all the code that you're executing, that they're providing your browser, is safe and friendly, and it's not going to do anything nefarious. However, as we're going to demonstrate sometime before Sunday, is that because there's that trust in the web server, that if for example, this PHP nuke site is compromised, and you're going to trick someone into executing some malicious code in the web browser. And for example, the idea of botnets is that rather than trying to send out emails and trying to infect people with viruses in that manner, and basically send out the payloads or send the attack to everyone, if you compromise a website, you can have them come to you. So rather than trying to overload your own mail server with sending out all these messages, you throw up a exploit that's in a QuickTime movie on something like YouTube, and then you start getting people just to pass around links to YouTube, which everyone, of course, trusts YouTube. It's not something that ends in a .com, .br, or some alphabet soup of domain names. So people come to the exploit now, so you have a huge number of potential victims that are going to a site with an assumption of trust, and you can exploit them that way. This was actually, there was an example of this over the Super Bowl. Over last December, January timeframe, that the Dolphins Stadium website had been hacked into, and a single line, about 12 characters of HTML were put in there. And it was basically a JavaScript that was loading a file from some other system that I think was hosted in Russia. But the site wasn't defaced, so there was nothing that made it obvious that a hack had occurred, and there was nothing evident to administrators or even to visitors, yet everyone who visited that website, if they were running an IE, they were being exploited by the animated cursor exploit. It was basically an exploit that had been public only about 30 days beforehand. And already, there's a compromised site that's obviously going to hit all these hundreds of thousands, perhaps millions of people coming to the Dolphin Stadium website. So it's a really interesting scenario because it's a subtle hack, and yet it's an easy way to get a huge pool of victims.
That's kind of karma, though, for running animated cursors, isn't it?
Well, it's karma from running Internet Explorer. This
Sure.
And of course, there's been other examples that on the German Wikipedia site, there were some hackers put up malware, put up viruses on a couple of the Wikipedia articles, and with the hope that people going through Wikipedia during the process of just navigating through the site, they would hit one of these viruses and would exploit their web browser. So it's real interesting that why bother that attackers are using public, well-known websites as basically drop sites or locations to spread their attacks against the victims.
So does JavaScript exploit buffer overflows to do any damage, or how is it, because this is running in a sandbox in the browser?
So JavaScript itself is a huge can of worms. So there's no JavaScript is basically it's interpreted by the browser. So it doesn't have an inherent buffer overflow unless there's a buffer overflow in the implementation of the JavaScript. For example, if you try and create an array with 2 to the 32 plus 1 character entries, maybe that will generate a buffer overflow. There may be something like that. But when you say sandbox, it's actually in a way it's a little bit misleading because the only JavaScript sandbox that exists is what's called the same origin rule. So that if you go to a website, that it will allow JavaScript access only to the HTML and the JavaScript related to that domain. So that way, www.google.com can't load JavaScript that will mess around with www.yahoo.com cookies or content or HTML. But otherwise, there's no sandboxing as far as pulling out your password or taking your password and sending it off in an image tag to someone else. And so we'll demonstrate that shortly about how JavaScript can be abused to take information from the user and then send it off to a third-party website.
But then in that case, how did that Dolphin Stadium, how did they point to the Russian site for the JavaScript?
So it's a script tag, and every browser is going to automatically load a script tag. And it doesn't matter what the domain the tag is looking at, because that's part of the design of the internet, is so that your website or HTML page can load images from one server, and HTML from another, and JavaScript from another, and CSS from yet another. So there's no inherent restriction.
If you want to see this to yourself, Firefox, download a plugin called NoScript, and then while you're browsing, NoScript will notify you about other scripts, and go, for example, MSNBC and then you see like 6 sites they're trying to download JavaScript from, mostly ads, the Google syndication stuff, and you can actually, with NoScript, you can disable each one and say only allow from this.
You may also find it very irritating.
What about local resources on the browser?
Right, so local resources, JavaScript is not allowed to access local resources unless it's loaded from the local host domain, and then it could, because that's the domain. So in that similarity, it's like Java engine. Unless it's signed, it doesn't have access to the local system. It can't open a socket or can't make connections. So there are similarities there.
So only information of the browser stores, like password, that the browser has access to.
Right. But imagine, JavaScript's pretty powerful, and here we can we'll show how rather than, an attack that exploits cross-site scripting, rather than just popping up a window as a proof of concept, we'll actually show some really complex JavaScript that's used for different types of information theft.
But if there is internet, there is no problem, right?
Well, technically,
It's all algorithmic.
everything's self-contained. Everything's self-contained within this laptop, and the whole point was just in case we couldn't get the networking to work, and then in the attempts to get the networking to work, we clobbered VMware's little virtual networking bridge in the virtual time. Yeah. So the laptop is currently context switching too much, so we'll let it move. So maybe we can start putting a face on some of these things that Mike started talking about. This is a PHP nuke, and it's version 6.5, which is like a year or two old. So you might call it a little bit of cheating because there's already plenty of known vulnerabilities for it, but it'll serve our purposes this evening. I did a quick Google search on a few unique attributes of the page to see how many hits I could come up with, how many people were running at least a version similar. And I got 23 million results out of Google. Now that could be multiple pages from the same site, so divide by some arbitrary number you can make up, and it's still probably a lot of sites. And if you follow web application security at all, or if you pay attention to the news here and there, PHP Nuke is not. They haven't stopped producing their vulnerabilities, so I'm sure we could easily update this presentation with a newer version of it. So the first thing we're talking about cross-site scripting, and Mike mentioned something about getting an alert pop-up box as a way to kind of know if you're able to run your code on through somebody else's web application. And so what we're going to do here is we've already found a place where we think that this might happen. There's a search box in PHP Nuke. And we played around with it a little bit, and we noticed that when we typed something into the search box here, and it inevitably searches, we get the information relayed back to us, right, in the result. We didn't get any results, but the string that we entered to search for gets kicked back out to us. It gets kicked out back here, and it gets kicked out down here if you can't see it. And so if the developers didn't do any sort of filtering on that, we might be able to cause a little bit of a problem. So we'll just, for this simple example here, throw in some script tags and see what happens. Takes us back to the front page. That didn't work. It turns out that PHP Nuke does do a little bit of filtering. They do kind of like a reverse firewall filtering, so to speak. So think of setting up a firewall, but instead of blocking all traffic and letting exactly what you want through, just think of letting everything through and blocking what you think is bad. That's how a lot of the filters work on these web applications, and that's what PHP Nuke implements in this version. So with a little bit of messing around here, we can in almost any case with weak filters, we can craft something to get by them. Copy this here. Paste it up here. And voila, we got an alert pop-up box there with the domain that we're currently at. So we'll look at the source really quick on this to see what happened. And remember I mentioned that it got displayed twice. First time in the search box and the second time down below to let you know what you searched for. And sure enough, down there, all the code that I put in there to cause that alert pop-up box is just sitting there for me to look at. We actually take advantage of a little bit of a flaw in Firefox, or maybe a feature, to get this to work, but it actually kind of helps for demonstration purposes because it highlighted the entire thing red. Basically what we did is we put an iframe in there, and we told it to load google.com, and once it got done loading google.com, we said on load fires, and we wanted to do this alert box. And then we just set the style to display none so it wouldn't show up in the page. And a little bit of trickery there, where we basically don't close the end of this tag. That's what gets around the PHP Nuke filter. PHP Nuke is looking for iframe, a complete iframe tag, and doesn't get it from us, so it lets it through. And we just capture the end of this bold tag right there, and Firefox happily renders that. So if you understand that, you might be able to see where you can take advantage of this. So we know that once google.com loads, this onload handler will fire and it'll run our code. So maybe we can do something a little bit more interesting. In a lot of cases, to make these sorts of things useful, you need to do a little social engineering on the user. And in this case, we sent our poor unsuspecting user, who we hope is logged into the website. Make sure he's logged in here. Yeah, he's logged in. We sent him this email and told him, hey, click on this link to our site, it might be useful to you. And, like everybody else who gets an email, it's so nice when someone sends you something and gives you a website to go look at. So, of course, he's going to look at it. And he'll open the link and pop up, and nothing, doesn't really mean anything. A lot of times people click on links, they thought they were going to go some other place, and they didn't. We just got this search result page back. Didn't mean much to us, so we just ignored it, thinking, we'll just go on our merry way. But on the other hand, the attacker has been watching this and is looking from his box, and this popped up there after he went to the page. That information there is the contents of the user's cookie, which allows him to access the site. So let me hop back over here.
When someone captures your cookie, how can you, are there timeouts for cookies, or are there...
That's a good question. It's really up to the developer. In some cases, like if you go to Amazon or other sites, sometimes they'll just set a cookie when you arrive there just to track you as an individual user, and it won't expire for 30 years or maybe never. And then that's always there. In some cases, applications tend to be very restrictive about it. They'll give you the cookie, and as soon as you close your browser, it goes away. That's a session cookie. In the case of our victim application here, they set a cookie that's good for a month. That cookie has some information that is actually easily crafted by an attacker if he knows some information about the target. But in this case, we don't even have to worry about crafting it because we sent him a link. Oops. That's, again, similar to the other one here. It had this iframe, but it's got all this garbage in it. And that garbage, you see down here, is actually a neat little payload in JavaScript. It says, once the onload handler fires, create a new image, and set the source of that image to this link right here, the attacker's web server, to this PHP script, and it's in the cookie, the document.cookie string.
That's the third string.
And the nice thing about JavaScript's image object is the instant you give it a source, it'll automatically go and retrieve that source. So without even knowing anything happened, it sent that, and we wrote that little imcap.php and just wrote that data into a file. And of course, if I'm the attacker, then I can take the contents of this cookie and go to my browser. Note that I'm not logged in right now. And these are two completely separate instances of Firefox, two different profiles. Just go ahead and add a cookie here. Or N is our user over there on the other page. So that's one example with cross-site scripting.
You'll see a little bit more of the text of that JavaScript.
Yeah, absolutely. Fine.
Yeah. We'll send you an email.
This is how JavaScript will transmit information to a third site.
Yes, this is
Without breaking out of its conventional security framework.
yeah.
There's no restriction. There's no restriction that a web browser can't load an image tag. So it's off-site, off-domain.
The same origin policy specifically deals with restricting JavaScript, CSS, or whatever from affecting or reading the contents of code that comes from some other place. It doesn't say anything about whether or not it can cause that content to be retrieved. And I'll show another example of that in another vulnerability towards the end of the demo section here that maybe illustrates it a little bit better. The final cross-site scripting demo that I'll show right now is something is based on what's called like a JavaScript worm. And it's not necessarily a worm in the sense of Mike was talking about, like maybe the MySpace worm that went through QuickTime, but it's that it gets inside of the browser and follows the user wherever they go. So again, we would use a little bit of the social engineering here on our user and send him or her an email. I'm going to log out here really quick for the purpose of this example.
Logged out too.
Yeah, I'm logging out. The user's logged out of the site here for this example. And he gets an email, and it's from the management, and it says, hey, log in here to see improvements. And if you don't get the login prompt right away, just go to your accounts. So I think, oh, cool, I'm being contacted to let me know that they've updated the site. Certainly I'll want to go to it.
But you can usually tell the link is good.
How many people look at every single link that they get before they click on it?
Well, certainly try.
Well, I certainly try to do it as well, and I pride myself on my paranoia. But I catch myself. The only thing I'm absolutely 100% positive to do every time I do it online is check that the SSL certificates from my bank's websites are valid. And no, you may not know who I bank with.
How do you verify that? Can you show people how to verify certificate?
Yeah, we can talk about that.
Yeah, we have at the end of the presentation, we have another demo that we'd like to show, if we have enough time, about cross-site request forgery. And it's something that it's a significant vulnerability, but it has to be addressed in the web application. There's nothing you can do at the Apache MySQL PHP layer. So when we talk about that, we can actually talk a little bit about the SSL certificates.
So our poor victim here, he clicked on that link, and of course, sure enough, it didn't ask him to log in, and so he's going to click on your accounts and log in.
Is this supposed to be J stupid or?
We don't want to let the browser remember our password. We're smart enough not to do that, right? We'll click on links. And we're logged in. So the attacker, on the other hand, has been watching this entire time, everything the user's done since he clicked on that link. Tells me what time it happened, where IP it came from, cookie information, and host payloads as well. That's the user's login and password. And in fact, you'll notice as the user goes through the site, and does more things, more stuff pops up here. And you know, as long as the user keeps this page up, as long as they keep this browser window up, everything they do is going to be sent back to you. Now, how this works is it's basically just some JavaScript that goes through, and once it's introduced, it goes and finds all the links in the page, all the forum posts, and wraps them and says, instead of letting the user click on this link or click on this forum post, I'll take care of it for them. And it just uses the similar tricks we saw before. It makes an image request to send the data back to the attacker, and then fetches the page using the XML HTTP request, and then replaces the content of the page with the data. It goes through all of it. So the attacker can watch everything that's going on. There's a little bit of a diagram. It's a little complicated, but it kind of illustrates how those last two attacks work. Attacker finds some way to get the user to click on the link, in this case the email. The user clicks on the link, the server responds with the cross-site scripting payload within the application, within the response. And then as the browser interprets that response, it will do the actions we tell it and send the data back to us. So that's some stuff that you can do with cross-site scripting. And actually I've I've seen one where you could actually remotely control the browser if you wanted. I could make that JavaScript ping my server every so often to, I don't know, say, get commands. Like, do this, do that, open a pop-up window. If it was Internet Explorer, you know, what's the contents of the guy's clipboard? That's where
the JavaScript is doing something like a loop and it sends stuff out and then it waits for more? Or is it one long statement and it sends it off each time you return to it?
It's up to the creativity of the attacker. So you could buffer keystrokes until you get a nice long, 1,000-character query string to send off, or you could do it on each one. In this case, too, all of the links were hooked, but it could also do something where it only hooks certain links or does so dynamically. So really, at this point, JavaScript is actually a pretty powerful language. So there's no inherent limitations on whether it would have to be that type of attack would have to be done one way or another.
If you could fix the application that the person was connecting to, so that each time they went in, they had to go through your attacker thing to click on, you could repeatedly find out everything that person's doing on that website.
Yeah, that's kind of how the worm works. So as long as I have a cross-site scripting vulnerability in every link to some of the targets on the page, I can affect that. So I can't, for example, make that worm load another page elsewhere and then get access to the content of that because of the same origin restriction. But if I know of, if say the user's clicking on a link to Google and I know of a cross-site scripting exploit to Google, I can then use that to keep the worm going in the Google context by resubmitting my payload in the.
Is this a vulnerability this would be true if the person was running any particular browser?
Yeah, and that's one of the reasons why we did it on Firefox on Linux here. To show that it doesn't matter. This doesn't just happen with Windows users on Internet Explorer. It can happen, on any browser. There are some exceptions to that for the text-only browsers. For those of you who still like links or links, yeah.
So is it contained to the way you code your web page, or is that?
Yeah, and we'll talk about it a little bit later. But for most of these vulnerabilities, it's just all up to the application programmer to deal with this stuff properly to prevent it from happening. But you can never have a perfect application. So
Never have the perfect program.
Or have the perfect programmer. Despite what programmers tend to think.
Mitigating this with Ajax, once again, excuse JavaScript.
Look that up the Ajax.
Oh, that's a whole other to do some way sophisticated attack.
Yeah, if
Yeah.
you start doing, if you do a couple Google searches on these types of things, then you'll see that a lot of these attack frameworks are using Ajax. Look for Java PDP Architect if you Google that, or if you go to or Google the name RSnake, and both of those will return forums and websites related to specifically web security and a lot of these types of attacks, very sophisticated ones.
One of our interesting review books over here is a JavaScripting book that has an entire 10 ready-to-go Ajax demos, and security is not even in the index book.
Yeah, actually, I think somebody made a comment on that. Actually, I think I saw it at Black Hat. It was a presentation, and they were talking about the fact that there's all these tutorials out there written by Ajax developers and web application developers in general, and they keep redistributing all these code snippets that people go in. I mean, most people who are doing this for a hobby or trying to learn it, they just go and they find examples and they cut and paste and they do a little bit of messing around with it, but the examples stay the same. And a lot of them don't think about security at that time. And what happens is that affects everybody's software, or at least everybody who's using those examples.
Sounds like one plan would be to go out and contribute some of your own example snippets
Yeah.
out there.
Getting educated or providing alternatives is definitely the way to go. But
And people have to use it.
yeah.
Yeah.
It's a tall mountain to climb.
There's
Put something animated in it.
No felony convictions yet either.
Well, yes. We'll head over here onto. We've got a few more vulnerabilities to talk about. So this is a problem that is probably more unique to PHP than it is to, say, Perl or any of the other CGI-based languages. PHP provides a mechanism to include arbitrary files on a local file system that it has access to. This is primarily for developers to include libraries of code to reuse over and over. It doesn't have to be PHP code, though. It can be HTML code, it can be a text file, or whatever. And if it's not PHP code, it'll just pass that data right through. The problem, though, is a lot of times PHP applications will use user input to base some of their includes. They base some of their includes on user input. And if they don't do proper sanitization, which is starting to become a theme here, we might be able to affect their includes and make it include something we want them to include. So I'll let Mike show this.
So in this case, we're going to go back to the attacker's web browser, so we don't need the victim involved for any of this. And just through normal perusing our payloads that we've been sniffing from the victim, we've got a cookie value here called length equals English, and then of course the user value. Now it just so happens that in this case, this English, the way that PHP Nuke handles its language templating for the website, is that it puts all of its locale-specific strings into different files. And those files just happen to be named, their name is based off of this cookie value. So we could come back to the site and we could try and edit our cookie. So in this case, rather than load the English file, we could do a couple directory traversals. And the first thing we could try, Etsy password. So we'll do this one, see if it works. And I was setting you up for disappointment only to once again show you some fun, so bear with me. So we changed the English file to Etsy password. Now, we got an error. So something didn't quite work here. Now, what happens a lot of times is mod security is turned off, right?
Yeah, but you need to change the port on that box.
Ah, very good. Is that a lot of times the way PHP can handle its strings, can handle their arrays of characters and binary values. So you can have a null byte in an array. However, when you pass that value down to the operating system, which is written in C, a null byte is a string terminator. So internally, what's happening on this website, instead of looking for the lang english.php file, it was looking for the English ... Etsy password.php file. So we needed some way of preventing this application from passing that PHP extension onto our attack. So what we do is append this null byte, which is a valid inside a PHP string, but it's a string terminator in the underlying operating system. So we fix our attack, append that null byte, come back to the site, and we have the Etsy password file. So now this has all kinds of uses. Right now, we're going to keep this in mind. We're going to come back to it and show a much more interesting exploit. We're only running as a context of the Apache user, remember, so we can't get the Etsy shadow file. So we haven't quite gotten all the way to root access, if you will, on this website. So we can't get any password hashes. We could do some interesting things, like now that we have some usernames, we can try and go look for some bash history files or some .history files in the user directories, or we can try and look for different configuration files that may exist on this web server. And they may have passwords written in them if it's a MySQL connection string, for example, something like that. So there's going to be a lot of uses we can do just to gather information, but what we're going to do a little bit later is combine a couple exploits to turn this into something a lot stronger. So,
but this one isn't really sanitation of input. That's just pure design of the application.
Well, is it?
I know.
That is a good question. Because, and one of the things that's nice to show this one off is in a lot of examples you see query strings, or you talk about changing something what you searched for in the search box. That's what Matt was doing when he was pointing out these cross-site scripting attacks. However, the cookie is still a legitimate attack vector, and the cookies must still be checked for proper input. In fact, what would have been smarter, since they know certain languages, is to use, they can indicate English, and then English is mapped to an array where it looks up what file it should use. So that's what really should have happened, rather than just taking this trusted value and putting that into a file.
What I was thinking of is that actually user profiles can be stored on this database on the far end, and then
and that would be just as legitimate. You could also apply the English language attribute to the user session on the server. That'd be just as better. That way they wouldn't be able to manipulate it. They could change it if they want to change from English to German or to French, but then they can manipulate it at no other points.
Something to remember about PHP, or something to learn about PHP if you don't know it. At least in the way Nuke is written, and a lot of applications are, the cookie data, the cookie values, that's like you saw Mike playing with, the GET requests, which are the stuff in the location bar after the question mark, and then the post data, which is sent when you click on a form, those are all combined into the same place. They don't have to be used that way, but a lot of PHP applications access them all from the same place. They get combined in there. So it is a sanitization issue to some degree. It is a design problem as well, but it's a sanitization issue because it's user input that I can modify and put stuff in there that the application wasn't expecting to get. Did we lose Firefox?
No, I was just making sure it was set for the next step. So what we've got for the next now, we're going to go and start attacking the database through the web application. And we're going to do this through a technique called SQL injection. What SQL injection is going to allow us to do is, through using only the web browser, modify some input like a search string or perhaps a cookie value, and we're going to rewrite the actual grammar of the SQL queries in the back end of this web application. So of course, most web applications are database driven. They select something from some table. We're going to actually change what those select queries actually look like. In doing so, we come back which other direction? We come back to the attacker and we look at this cookie value. Now Matt's already demonstrated we can replay this value and it's automatically going to log us in because this cookie value is used to identify each user. If we took a closer look at that, we can see that the cookie value is not actually encrypted is actually, whoops, it's base64 encoded, and base64 encoding is just a colon delimited string of characters. So we have a number, then we have the username, we already saw our J Tupson, then we have a hash value, which looks suspiciously like the same length that an MD5 hash would be. Then we have a few other items. Now, to set up this attack, before we show it off, this is what our cookie looks like. Inside the code, this is how this cookie value is being used. Our user parameter is basically does a base64 decode, then it explodes it, so it separates it based on the colon into an array, and then it takes your user ID, which is the first element, number 1. And then it just takes that and it selects the password from this table where your user ID equals, in this case, 1. So throughout all of the steps, there's absolutely no sanitation or no input validation being performed. So there's a couple really cool things we can try to do now. Either we can try and modify some of the data, or we can try and inject some data, or we can try and read data. But we're going to take advantage of a particularly interesting thing that's specific to MySQL, in that it called its into-out file capability. In other words, you can select some data and write that into a file. And the only restrictions are that you must have write access to the directory you're trying to put it, and the file cannot already exist. So, for example, we wouldn't be able to overwrite the etc password file with our root user with no password, but we can try and create an arbitrary file. We're just going to try and write a file to the web document and see if that.
You're going to create a what file?
A file that has any content we want. In this case, I'm just going to try and create a file, an empty file, just to see if the attack works.
Yeah, anything. Doesn't have to. All we need to know is if his query is successful, will we be able to find the file?
This evil hello world, as it were?
Yes, exactly.
Yes.
Evil hello world.
Can you store it in the database or on the file system?
So in this case, we're using a database query to create a file. And in this case, I try to create a file on the web document root. So if you see, I'm doing a union select. So I'm taking advantage. This would only work in MySQL 5.0 or later. But I'm selecting the number 1 into out file called ./foo. So basically, I'm trying to create a file called foo in the web document root. And right now, that file is only going to contain the number 1. So right now, it's a proof of concept. We're just testing to see if our attack is viable. And then we're going to build on this. We're going to unleash a Matt against the website, and he's going to show how to really compromise this. So of course, I tried that, and what I would do is I get no feedback in my web browser if it exists or not. And I try to open this file. Now, it wasn't created, so in this case, either maybe my attack didn't work, or I don't have write access to the web document root. However, a bunch of Linux users in here, what's a directory we're pretty much guaranteed to have write access to? /temp. So, what we try and do is create a file in the /temp directory. So I do that, and what I've done is, in the URL, I've put the payload of my cookie. Because one of the quirks of PHP is that you can take a variable and it can be placed either in the get string, a post data, or a cookie, and it all counts as the same. So for quickness, I've just put this my user in the query string. Now, so I've just tried to create a file in temp. Unfortunately, at this point, I can't read from that file yet, right? Because it's not in the web document root. Well, if we go back and we use the other attack where we use that etc password, and I edit my lang cookie, I can try and see if that file was created. So I reload this page with my modified cookie from the previous exploit that we used our directory traversal and file access to, and we can see that instead of the etc password file being dumped out, we had the user password, and there was the number 1 that we appended to our select group. So if you remember that original, it was selecting the password from the database where the user ID equals 1. So that's why we see the password hash. So we've got a SQL injection capability now where we can write whatever we want out to the file system. And that's going to set us up. So we're taking baby steps now. We've compromised the user pretty well. We've stolen their password. We've stolen their cookie. We've put a worm in their browser. We can read a couple files on the web server, and we can write some files to the web server. But now we're going to put Matt in the hot seat and get him on tape so we can use this for federal prosecution later and show how to fully compromise this web server.
Okay. So before we get on to that, PHP also has another unique characteristic in its default implementation that allows it to, remember we said we can include arbitrary files from the document root, or the file system. PHP can also include files from arbitrary URLs by default. So let's say that we share some code with another website, and it's library codes, and we might use a link and include to that website to load that code and share it that way. I don't really see that happening in real life very often, but nevertheless, PHP developers decided to include the capability. And so if we, the attacker, know that this capability is turned on, we might be able to take advantage of it to get maybe more powerful payload in there, something that we might not be able to fit into an SQL query, because there might be some restrictions on how much data we can send to the file system, or send to the SQL server, and maybe how much space is left on the file system. So we're going to put this whole thing together now and kind of see what we can really do. And this is the quick diagram. So what I'm going to do is I'm going to run a similar SQL injection query to what Mike showed, and then I'm going to request the page with the exploit. The server is then going to request a file I told it to request that I put in that temp file, and it's going to respond back with shellcode, kind of like shellcode, and I'm going to get a shell on the box. I'll sit down with this. So, clear out the cookies. Got that for now.
So you logged in or not?
Don't need to be logged in for this one. So, as you can see right here, this is the query that we're going to send.
If you mouse over, it'll show what the decode is.
Yeah. Maybe. Right there, we're going to tell it to put into a file, the remote include to the attacker's website to load this ps.inc file. And this ps.inc file is just a bunch of PHP code and a little bit of HTML for rendering purposes.
Is that on the attacker server?
This is on the attacker server, Mallory attacker. So let's find that link.
And we're going to be extra sneaky with this attack because if you remember, these are colon delimited fields, and our payload has a colon in it, so it's HTTP : / in our attacker box. So we had to actually base 64 encode our attack so that it wouldn't be disrupted inside of the PHP, inside of the PHP nukes internals.
So we called the name of that file, we called it temp PHP. So I'm just going to pop over here and then the English cookie.
So Matt executed the attack, so now what he's doing is reading the file.
That's the FBI conference.
And after I reloaded the page with that cookie changed, I now have my shell.
Can you, well, at that point you could just SSH in or some.
I could set up my
Yeah.
first SSH tunnel. I could set up netcat to listen and let me connect. There are some restrictions with that though, because of we'd have to do a little bit more PHP manipulation because there's maximum execution times that are set by default. So it can't sit with an open process for too long before it gets killed off.
This is all running over HTTP.
This is all running over HTTP, so no interactive
Firewalls.
Firewall has no idea what's going on, and also what's really interesting from a forensic standpoint, very little of this is actually been logged. It shows up in your Apache logs. How many of you are actually logging cookies in your Apache logs? So all the attacks we've been doing in cookies, you'll have no idea that's how you're compromised. And if you're looking at the URL, this index.php, that's not a very suspicious URL. It will be a little bit suspicious because we're sending commands like ls-l and id and whoami and possibly rm-rf to this index.php file. But from a forensics or an incident response viewpoint, this is going to be really hard to respond to.
Another thing I might be able to take to my advantage is I did an ls in the directory that it was running, and I found the configuration file for PHP Nuke. And that includes login and password information for the database. And if you look at a lot of web servers out there, especially these self-contained web servers, sometimes people forget that MySQL doesn't need to listen externally for incoming connections. So if I can get this information, I might be able to use my own MySQL client to connect to the server and do whatever I want within the context of MySQL. And maybe there's a nice little root exploit that I can run to get direct access to the box that way.
And it's important to consider here, we don't have root access, but technically we don't need it necessarily, because we've compromised the website, and at this point we would have access to the data in the database. We've been able to compromise users. So consider that we've attacked the information and the jewels of this web application, this web server, and we didn't have to get to root. So it's one of the things to keep in mind when we'll talk a little bit about mitigation, is that root does not have to be the end game. And so always focusing on protecting root must be protected, may make you not consider all of the other security steps that you need to take to protect the data that's related to your web application.
So with a couple of simple things stacked on top of each other, we got direct access to the box to do quite a bit of things. We'll switch gears really quickly to a different kind of vulnerability before we talk about mitigation here. And we kind of alluded to this earlier. Cross-site request forging is a interesting web application vulnerability in that it's kind of a side effect to how HTTP works. Basically, it takes advantage of the trust that a web application has in its users. The web application expects that the user is always going to validly access the authentication when they're authenticated, or when the application knows the user. And if the attacker can get the user's web browser to make some of these requests, like we saw earlier, these little image requests, they might be able to you might be able to change the state of the application as the user. That's a little bit hard to understand, so I'm going to kind of show a demo for this really quick. We can talk about this a little bit more after the presentation, but the important thing to note is that none of the stuff that we're going to talk about with respect to the systems administrator's role in securing these applications can fix this. This is something that has to be addressed by the application developer. And even to some degree, the application developer can't prevent it 100%.
So while he's getting it set up, previously, all of the exploits we demonstrated actually targeted the web application. Cross-site scripting meant that there was an input validation issue in the search box, and so we were able to get some of our arbitrary code in there. SQL injection meant that cookie value wasn't being properly sanitized, so we could rewrite the query. In this case, what Matt's actually going to do is demonstrate another social engineering. We're going to give away a free iPhone. Oh, cool. Exactly.
Everybody wants that.
Give us your email after the presentation. And what the payload is going to do is actually just make the victim's browser automatically execute a couple of steps to PHP Nuke. So in this case, there's no vulnerability in PHP Nuke that we're exploiting at this point. In fact, Matt's going to be exploiting the victim's web browser in order to pull off this attack. So there's a bit of a nuance there, and that's also why we're highlighting that the mitigation strategies for this type of attack are extremely difficult.
So here's a quick flow of the attack. The attacker is going to get the user again to click on some link that you supplied. And this is actually, in this case, this is a completely separate web page hosted on a completely different box, the attacker's box. And the victim's going to load that. And as soon as he loads that, it's going to make a malicious request to the application that trusts that user. The user's logged into the web application, he has a cookie for it. And so anytime he makes a request to that web application, the browser says, oh, you're accessing your PHP Nuke site, I'm going to send your PHP Nuke cookie. And we'll see that once the victim has clicked on the link that the attacker sends him, the attacker will be able to access the web application as him. So we get a little link here, and we say, sure, I want a free iPhone. So we'll open this up, and yeah, I want a free iPhone. I just text this number text this little information here to some number, and they'll send me the information, I'm sure. So I'll happily text that in there and send it, and I've given away my phone number, and I never hear back. I think, just another letdown. In the meantime, you may notice that the web browser isn't done loading this page. In fact, it's still spinning, and it says it's waiting on demo.box. But I'm at winner.freeiphone.box. I wonder why that's happening. Let it finish.
Let's find out.
It's done. So
This is what phishing email they do.
this is something that you could do with a phishing email. Not that we're recommending that you do it with a phishing email, or do it at all. So we'll go back, and if you recall, I said that we were logged in. So now let's click it. No, we're not logged in. Why not?
So you were logged in first.
I was logged in.
This is the victim browser now.
This is the miss. No. It doesn't work.
So I remember that it was password 123, remember, that we did the capture. So for whatever reason, password 123 is now failing.
It's funny that there's a security code, right?
Yeah. It's in the security code.
Meanwhile, on the other side of the world, perhaps.
Meanwhile, back in Nigeria.
So now this is our attacker web
This
browser.
is the attacker, and now the attacker for this particular example kind of has to know something about the person that he targeted. He needs to know his login for this application. But he found him, talked to him via AIM or something for a while, and finally figured out what this guy's username was for the application and sent him the phishing email. And
Well, let's see how they got that new password first.
no, okay.
Otherwise, they don't know how that's.
So let's look at the source of this. So we said before that this thing was just spinning for a while it was doing its magic. And if you look at the source code here, at the very bottom, it's another one of these iframes down here. And again, it's set not to display anything, but it loads this iframe.html file. And fortunately, the browser will run it if I request it, so we'll just go in and look at it here in less.
It's spinning.
Yes.
Just a
No, it's just the
calling of the fish.
I'm sleepy.
He's found an exploit in us.
So basically, that's the occasional screwball website that we all went through a couple of years ago that kind of needs a lot of replace. That's it.
Why not? So really quick here, I just sent it this set of this JavaScript code, and the JavaScript code just has this link here to this page within PHP Nuke that I figured out ahead of time, and I want to set the user's password to something I know. So I'm going to set it to new pass. Now I'm going to try to set my email address as well so that I can get email notices instead of the user. But unfortunately, there's something wrong with the code in PHP Nuke, and it won't change the email for anybody. So that doesn't work. But one thing I have to know in order to change the user's password on the target is his user ID within the application. And that's something that maybe even the user himself doesn't know. It's just some number that identifies him uniquely in the database. Well, I figure that I can brute force this. There can't be that many users on that website. So I'll just set up JavaScript with a little for loop here. And in this case, I went from 0 to 100, but I could have gone to 10,000 or 20,000 or a million. And I just said, every time you loop around, create a new image and set the source to this, and each time increment the ID one more. And maybe you'll get lucky. And sure enough, we pop back over here from the attacker's web browser with the password ABC123. We're in. I didn't break same origin policy. I didn't do anything fancy. In fact, I didn't even need to use JavaScript. I could have just had in that iframe 100 image tags with their source equal to that same URL with the ID incremented each time, and it still would have done the same thing.
But this assumes that user has an account in that PHP.
Sure. Like I said, this is something, these attacks tend to be more targeted. Something you have to know a little bit about the victims. Not always. Like one of the earlier examples of cross-site request forging, somebody emailed the full disclosure mailing list illustrating how he was able to change information in people's Netflix accounts that went to his site or went to a site. Change the bill to the shipping email address, change the user's favorites or watch list or something like that. And all he needed to do was get it's kind of like how what's the word? How banner advertising works. You get millions and millions and millions of hits, but every once in a while somebody clicks on that and says, I want to buy. And so if you get these sorts of attacks into places where a lot of people will visit, almost inevitably you'll find somebody that happens to use the application you're targeting and happens to be logged in while they're doing it.
So typically most applications, when you exchange a password, you have to give you an existing password.
Yes.
So
typically.
That points out in this one particular instance, the fix here would be prompt for old password before you change the new password. So that would be one way to mitigate this specific vulnerability because we didn't know what the old password was. So there is a problem in PHP Nuke in this version that it allows you to update your profile without verifying that you knew what your old information was, in other words, your old password. But think of this also in the case of banking, for example, to trade from one account to another. If it doesn't require any additional confirmation, or if you can use this type of attack to automate that account transfer phase, you don't need to know. That would be a financial impact. That would be a way that an attacker would actually get some financial motivation out of this type of exploit.
Again, oversights in the programming. You think, oh, the user has a cookie, nobody else can have that cookie, so as long as he gives me that information, I know it's him, and I can do this action.
Yeah,
so
it's a good observation. Yeah.
So really, we're basically browsing other web applications by proxy. We're using the victim's web browser as the proxy in this case. If that helps illustrate a little bit better.
the lesson is to always, when you go to financial sites, open a fresh copy of the browser. I mean, no, seriously.
In that case,
yeah,
well, if you start out right, if you started out only going to that website, then you would be fine.
Okay.
In this case, in this case, it required the user to have been logged in, I believe, and they would have had to have been logged in, and they would have simply had to click on this link, the free iPhone site link.
I personally have a separate web browser that I use for doing stuff like that I don't do anything else on. like I said, a little paranoid, but you know, I'd rather be a little bit paranoid than be broke. So
That's why people use Opera.
you know, but it doesn't even Opera. I mean, Opera's not any more secure with respect to this attack.
Just having another browser though.
Like having another one there, you know, whether it be Opera, whether it be a clean Firefox profile.
Well, I think what people were talking about doing is using appliance images to just web browse a particular site and then destroy the whole image, like using DNSlayer or something.
You use a live CD.
Yeah, you use a live CD or something that doesn't write out to a persistent cache. That's just your level of paranoia. That's what it has to be effective.
It's a trade-off between how paranoid you are and how lazy you are, in a lot of cases.
And also, do you save your configuration to your USB key when you shut down your live CD?
Just a little comment to that. I don't know what the current state is, but in IE 5.5.5, if you started like a new browser window out of the existing browser window, they share the context. But you can have 2 instances of IE if you run it from shortcut from desktop, for instance. And those 2 windows do not share the context, which is something that Firefox by default doesn't do.
No, Firefox will automatically, it'll look and see if Firefox is already running. If it does, because when you run Firefox, it's just running a wrapper.
Yeah.
And it says, hey, is Firefox running right now? And if it is, it says, oh, we'll open a new window instead. And that's why you can force it with the dash profile manager option. Launch it with the profile manager, and you can create a new separate profile like My Banking or something like that, if you care.
And all you want is another browser window, you just say -no remote.
Okay.
So are you saying that if you start a new go to Firefox, a new browser, it's the same process? Different threads?
I mean, it's not the same process. If you click on, are you talking about if you click on Firefox and it's already running?
Yeah.
Yeah, it's the same instance of Firefox running effectively.
And so they can access each other's in-memory cookies?
They access the same profile information.
Profile, I see.
Yeah.
Not same session cookies.
Not well.
Yeah.
They're
Remember too,
Session cookies, yes.
running 2 different browsers is still good, but you make that one browser you're running, it has to be the browser you only use on a handful of sites. The real issue here is that you've gone to an attacker's site that's caused your browser to do something. So if you're running two different copies of Firefox, and one copy you only use to go to your banking and that's it, then you'll be okay from this type of request forgery because you're not going to any sites in that browser that's going to redirect you. If in the other browser you go to your banking website and all these other sites, then you're still exposing yourself. So you would have to, that becomes a user issue and just sort of your personal, browsing policy that this browser is for your porn browser, this browser is your other browser, and this browser is your bank browser. Never, and they just don't overlap.
Multiple user accounts.
Yeah, multiple. Yeah, there are a lot of approaches, but at that point, it's your diligence about safe browsing. Well, you haven't asked a question.
Are you aware of any plugins or script monkeys or anything like that one could install that would, for example, not allow JavaScript to talk to a page other than the one it came from? Because there are, I think if you were to limit the scope of what kind of cookie exchange is allowed and what kind of JavaScript connections are allowed, maybe with a dialog box saying you really want to allow this, you could prevent all of these.
You could, and there are no script. The no script extension is a start towards that. And on some web application security mailing lists, people are starting to discuss, or rediscuss, I should say, something that they were talking about 4 or 5 years ago about content restrictions. In other words, saying that this website you go to is not allowed to call out to any other domain. Of course, that can be effective, but you still run into implementation issues because even though we were showing, for example, using image tags, we could do all of this cookie theft. We could be really smart and do it through DNS queries. I could rewrite your cookie as a base 32, or I could just use the characters that are valid for DNS names, and I could just cause your browser to do an NS lookup. on your cookie string.attacker.com. And then I just, instead of watching my Apache logs, I watch my DNS records. So now, of course, if your browser sees that that string is not the same domain and it doesn't do the NS lookup, you're protected. But if it were to do the NS lookup and then say, well, I'm not going to call out sending requests, you've already leaked that information. So it's still it's an arms race, if you will. And content, this idea of content restriction is what people are discussing right now about, can this be an effective way of limiting phishing, limiting cross-site scripting, these types of attacks? But it's a lot easier to describe something, especially right now, than it is to implement it. So.
And we just got to the first part of what you guys know is the system or a working procedure for tightening up your website. We have to come back for another presentation.
Do you know what's amazing? 2 days ago there was an article about iPhone being hacked. So is that same as what you just explained? They send a character to do a buffer overflow and then read.
Yeah, in that case, I believe it was actually a buffer overflow in Safari that they sent, that if you could lead somebody to your web page, then they would load it and you actually overflow Safari. Now that's something that's specific that can be patched. A bug fix can patch that. But everything that Matt was showing with the cross-site scripting, Safari is a web browser that executes JavaScript like any other. And so all of those, a browser is a browser that executes JavaScript is going to be susceptible to these attacks, in addition to this one that Matt just demonstrated.
So JavaScript can't be rewritten to clean this up.
No, it's not a JavaScript issue, it's a browser issue, and HTTP protocol issue.
I mean, if you're going to have scripting languages, applications, there is just no way to have something execute on the client machine that can't be hijacked if they can do anything to put the code out there.
Right, I mean, it boils down to the same consideration, for example, of wares. If you're someone who goes out and tries to look for wares, sure, they may be executing, and you can run your latest Quake or whatever currently you want to be running, Microsoft Office, what have you. But who knows what else is in that binary? That could be a Trojan, it could be some other type of backdoor. It's a very similar execution. That's your execution environment from your command line, from Windows, for example, or from Linux. It's the same corollary with the web browser. Rather than talking about binaries, you're just talking about JavaScript code. So you're basically trusting other people to execute code in your web browser. This code can do whatever it wants, hopefully within the restrictions of the same origin policy of JavaScript, and that you trust that all these websites you're going to are executing polite code, or they're executing good code against your web browser.
Now, how does HTTPS play into this one? I mean, for a bank, you'd have HTTPS.
HTTPS has no variant. So in this case,
secure exploit.
Yeah, exactly. You have a secure exploit. So now your IDS didn't catch it. That's all.
Here's one takeaway from what Mike was talking about and the same origin policy. We've said it a lot, and we said same origin prevents this. We can get around it this way a little bit, but at the end of the day, it still makes a lot of these attacks really difficult. So consider that that's the linchpin in the browser. If somebody figures out how to break same origin, then all of these more sophisticated attacks to do things to the users suddenly become a lot easier, because then I can arbitrarily read and write to all these different places that I'm pulling data from. So if same origin is broken, you might want to start going to your bank teller directly. And bear in mind that a lot of the development community, especially the Ajax developers, want that to happen. They don't want to. They don't mean it maliciously, but they want the ability for their Ajax, their JavaScript code, to be able to read and write from different websites.
Well, no, wait. The business of HTTPS, which is an encrypted, authenticated connection between you and whoever you connect to, it does not preclude any of these attacks.
Right.
If they get their code up on that page that you are accessing, even an HTTPS session, when that piece of code executes on their machine, the possibilities that they are active.
If I get it coded to your browser, attach.
Exactly.
And if they can stick it on the secure website, you're in.
Yep, yep. That's it. Yeah, SSL doesn't have any bearing on these specific tasks.
So, I think our articles are running Apache, I'm not sure if it's still alive, I'm running, I don't know how to pronounce it, Chroot, CH
Yeah.
Jails. Is that the reason why we can't read and write files?
Yeah, we'll talk a little bit about that. That brings us to countermeasures. And Chroot and jails, BSD jails, those can have bearing against some types of attacks, but for the most part, cross-site scripting wouldn't have been effective. The exploit where we created a file for the PHP shell that might have been affected if the entire Chroot environment was read-only, but if there's a /temp that you can write to, then you're simply writing that file to the temp in the Chroot, and that doesn't matter because we just wanted to write and then execute it.
So we'll talk a little bit about countermeasures here, and before we do, there's a few other configuration issues with some of these technologies that you need to kind of consider as well. With PHP, we touched on the allow URL open. That's the include stuff, the remote include. The idea that include files can use a URL to pull data in. That makes some of this stuff possible. Register globals is a unique feature of PHP that allows any data that I send to the user to be exported into the global namespace. So anything that's after the question mark foo equals bar inside of PHP becomes $foo, or if it's a post variable, or if it's a cookie value. So you saw the snippet of code Mike put up earlier for the SQL injection where it exploded $user after it decoded it. Well, where to get $user? It just simply existed. It was there because it was sent in the cookie. And register globals thankfully has been turned off by default in PHP 5, and it will be gone in PHP 6. But it's actually, if you've done any PHP coding or if you followed any web application scenes, you've probably heard about it before. Another thing with PHP is its error reporting capabilities. A lot of information can be gleaned by causing the application to do something unexpected. Like, it was expecting a number and you gave it a letter. And it didn't know how to handle that the way it was being used. So it spits out an error. And a lot of times those error messages say exactly what file, what full path that file was, what line of code it was. And a lot of that information can be used to figure out where things are on the web server and how the code is structured. With Apache, there's a whole slew of things that Mike will talk about in a little bit to deal with as far as configuring it securely. Apache directory indexes, if you ever gone to a web page and it was just simply a white page with a kind of like a file listing, if you forget and leave those on, it's free access to look around the server. You never know what kind of interesting things people will leave on there. The server signature, you don't see it by default with the web browser, but if you can telnet to the web server and ask it, it'll tell you exactly what it's running by default. Apache 2.x.x, PHP x.x, OpenSSL, which will be really useful if you know of some specific exploits for those versions of the Apache or any of the other underlying technologies there. Unnecessary methods are also something to consider as well. HTTP kind of provides a way to have a whole variety of different methods to do different things. The traditional ones that we use in web applications are going to be get, post, and head to get or send information. There's also a whole bunch of other things that are related to web dev, which is putting files onto servers, getting files, and things like that. So if you don't need them, if your web application doesn't support them, why would you enable that in the first place? Another thing is trace and track. These are methods. Apache has trace, which is a debug method. It'll, basically, anything you send it in the headers and in the content, it will send back to you. And there are some ways, we won't get into tonight, that you can take advantage of that to do some of the cross-site scripting stuff that we were looking at And then on MySQL, there's also the issue of privilege separation for accessing the data in the database. A lot of times when people put together an application, you know, they download PHP Nuke and they want to install it, they create a user in the database and they give that user all the permissions to create the database schema, to load the data in there, to delete data, maybe sometimes do file operations like into out file, which you saw earlier. And you know, restricting those permissions to exactly what is needed for the application to run is always going to help. But a lot of those oversights really give the attacker a lot of information that seems kind of trivial at first to have some of these more complicated exploits happen.
So we'll finish up with a couple highlights about mitigation strategies, and we'll point you at the end. We have some references that are some in more detail about what would be useful to go through step-by-step checklist, that manner. But what we really want to highlight is that if the vulnerability is inside the code, it has to be fixed in the code. All these secure configurations should be an integral part of your deployment policy and your web server deployment. And it can mitigate the impact, and in some cases it actually can block certain exploits from occurring. So it's a good stopgap measure, it's a good defense in depth strategy. But at the end of the day, you need to sit down and go through that code and fix all those vulnerabilities that exist inside that code. Now we just have to stop for a commercial break.
Sorry.
Oh, is there a website I can go to and figure out, okay, what are the things I need to do to secure myself, you know, if I'm running a web server?
Sure. At the end, we have some references. For example, there's the CIS has a list of Apache secure configuration and recommended policies. There's a site called Hardened PHP or PHP Security. Talks about hardening PHP. There's the MySQL website has some snippets about some more secure configurations for MySQL. And we'll cover each of those in the next couple of minutes. We'll start with Linux, saying basically one of the best things that you can do, that even though your firewall has to allow 18443 incoming, because that's what the web application listens on, that's what you need to make it work. If you block outbound connections, then you can mitigate a lot of what we did here. For example, the remote file include, where we pulled across our PHP shell from another server. The Apache web server initiated that outbound request. So basically, if your firewall blocks outbound SYN packets, outbound connections, then you can gain a greater level of security right there. Your web server should always be responding to requests, not initiating. Of course, you always run services with least privilege. So run Apache as Apache, or perhaps in a root environment. Current patch levels, of course, are important. If there's a buffer overflow for the version of OpenSSL that you're running on top of Apache, there's no need to start looking for SQL injection or cross-site scripting vulnerabilities. So we can get through that very quickly. And if you have time and lots of patience, you can experiment with SE Linux or with other kernel hardening techniques. What those do are limit they apply role-based access controls to processes and files, and they really fine-grain control about what can be read, what can be written to, what can be opened, how many threads can be launched, for example, these types of things.
Say on SE Linux, Ubuntu has something of an SE Linux beginning notion of it, and Debian does. And do you recommend that that's a platform to pay a lot of attention to for development?
Honestly, from the web development perspective, I'm absolutely neutral to the server, simply because in my experience, what I work on are hacking the websites. So it doesn't matter if it's in ASP or .NET or PHP, Perl, Python. They all seem, if it's poorly written, you can take it apart. And typically, also, I'm going after the information. In other words, what's in the database, or can I impersonate another user, or can I steal another user's information? And from that perspective, then SE Linux or these hardening or other similar things have no bearing on those types of attacks. So that's why I would a little bit punt the question and say that all in all, those are good from I'd say go with whatever you feel most comfortable with, or whatever system administrators like, because at the end of the day, it's the application layer where you're going to have your vulnerabilities. I don't know if you have a different perspective.
No, I agree with you. I was just going to say that with regards to SE Linux, I'm pretty sure that it's part of the kernel now, and Ubuntu and Debian are both just using the stock kernel, and it's just the same SE Linux that the NSA had developed and released. So it's again you need a lot of patience in order to run with it, but it should be the same one that's in Red Hat and on any other distribution that claims to have it on there. It says SE Linux.
What about kids like GR Security, which aren't related?
Well, GR Security kind of
that helps for buffer overflows.
Mm-hmm.
That's for buffer overflows, format string vulnerabilities. But those are also the types of attacks that are very uncommon, if not non-existent, at the web application layer. For example, especially if it's an interpreted language and not a compiled one. If you're writing your web server in C or C++, then those may be useful because you're exposed to buffer overflows more likely than you are if you're on Java or PHP or at the Apache layer, of course, we already mentioned running Apache as a limited service. There are a few things you can do to mitigate certain exploits, or basically to block scanning tools. Rather than blocking hack attempts or exploits, you can block certain tools. Some of the things you can do are actually just limit the size of requests that are incoming. You can limit the request line, which is the URL string. You can limit the request body, which is the post data. And what that simply does is that if us as the attacker, we're trying to send a string in the URL that's 5,000 characters long, but we're limited to 255 characters, well, at the very least, Apache is going to block it, and Apache is going to block the web server, so it doesn't have to pass that request on to PHP. PHP spends some time and resources parsing it, and then maybe it has to pass that on to MySQL and spend some time and resources parsing that. So you can, if you know, for example, that your URLs aren't going to go past a certain limit, then you can implement this. Anything past that limit, you can just get rid of, and that way you don't have to dump all that extra processing power onto your application engine or the backend database. It's not securing you, it's just possibly a performance, improving some performance, and possibly reducing canned exploits or script kiddies or sophisticated attackers coming after you. Another thing you can do is, again, stop scan tools by using the mod set environment and looking at the user agent header. And if this user agent header contains anything in this regex, you can set this scan tool environment variable, and then you can deny anything from it.
That's trivial to avoid that.
Exactly. It's trivial to avoid. Because anything from the client can be modified. That's why I call this, that's why the emphasis here is on scan tool as in its default configuration that has been changed. It's not going to block hackers or actual exploit attacks. And everything we did with the browser, of course, it's not going to touch at all because it's not the browser's user agent matches none of this. So that's why I'm talking about mitigation strategies, and these are steps you can take to try and reduce the total number of attacks coming in, because you can block the script kiddies, you can block people who are running NICDO scanners, something like that, but then you're not going to block people who are sophisticated or actually targeting your web application. And the reason for that is that a lot of these vulnerabilities go back to the application layer, and that's where they have to be dealt with. A couple other things you can do is also you can control Apache to block access to certain potentially sensitive files. For example, if you are in a production environment and the reality of your situation is that production and development are often intermingled, and there's a little bit of confusion about what web servers should be in development and should never go on the internet, and then which ones actually go on the internet. You can do things to protect CVS directories, subversion directories, those types of things. Remember, however, this only protects at the Apache layer. So that local file included tag, where we read the SE password file or those files from the temp directory, any entry you create here will be bypassed by that attack we did. So there's no way you could say block any file that matches SE password and prevent that from being included. We would have gotten around that because we went through the PHP layer, not directly through Apache. Apache Mod Security has is probably one of the best things you can do that will actually protect your web application. Mod security is it's open source, has a large community behind it, and that community has generated a lot of rules that are useful for just a default configuration. Just install mod security, turn on these rules, and cross your fingers and hope that it doesn't impact your web application. But you should get a lot of protection against basic types of attacks like cross-site scripting that we were demonstrating and SQL injection. Because it's basically doing pattern matching and all the data coming from the web browser into the server. So of what we've mentioned so far, if you were going to do one thing, mod security would probably be the best one to consider. Well over SE Linux or spending or doing all those tweaking on directories in your HTTP.conf files. This one would be the way to go.
Don't use it with the wiki though. We had it turned on for Penload and it was practically impossible to edit the pages anymore. Because they were talking about like...
And that brings up it. And what we're going to show at the end too is that we'll try, if we have time left over, we'll run through some of the attacks that we did. And mod security would not block all of the attacks that we demonstrated tonight. There's a few of them that would get by it. So even having mod security, especially if it doesn't impact your normal uses of the web application, it's still not a panacea because it's not going to block every type of exploit, even the simple ones we demonstrated tonight. For PHP, probably the one that I would focus on most is registered globals. You can have the most secure PHP application, but if registered globals are on and users are able to pollute your global namespace by any get parameter or post data or a cookie value, then it's game over. Your web application can and probably will be compromised. Because with registered globals turned on, it can be trivial to bypass filters, to overwrite variables, and to do lots of nefarious things against the website.
And PHP's default is on.
PHP 5.0 default is off.
Okay.
PHP 6, they're getting rid of it entirely because it's caused too much headaches. It actually encourages bad programming practices, so they're just getting rid of that one, along with safe mode and magic quotes as well. One thing that we could highlight too is the disable functions. This can be a useful one if you're really paranoid, because you can block certain functions that are known to be misused, abused, or highlight significant security vulnerabilities. For example, the PHP shell that Matt was using when he was typing ls-l getting directory listings, that was using the proc open function in PHP. So if you had disabled that, then Matt's attack would have been foiled, and he would have had to go back to the drawing board, craft some other custom PHP code to pull off those same types of attacks. And that would have been possible, it would just raise the bar. If you had disallowed remote file includes, it also would have made it a lot more difficult for Matt to pull off those exploits. As the joke goes, the idea of raising the bar goes to the idea of two guys talking about going through the woods. And one guy looks at the other and says, hey, why'd you buy some new running shoes? You know, we're out in the woods, we're going hiking, what's going on here? It's like, well, I'm really worried about bears. It's like, what are running shoes going to do to help you against a bear? It's like, I don't have to outrun the bear, I just have to outrun you. So, if you raise the bar, get people to go after someone else, perhaps that could be part of your security policy. There's also MySQL we can talk about. Probably with MySQL, if you want to disable the file privilege. That's how we were able to use this into-out file. We were able to create arbitrary files on the file system. And you basically want to apply the idea of least privilege access inside your database. So rather than having your root equivalent database user run your web application, then you create a specific user for your web application that only has access to that specific catalog. And perhaps you have two users. One that is a read-only account that's used for all of your read queries, of course, so your select statements, and then another one that has insert or update access that can actually write to the database. And that way, too, you can actually further restrict the amount of the impact or the potential scope of a compromise that an attacker might pull off. Connection strings are always difficult to deal with because typically, especially in PHP, they have to be in plain text. Matt was able to go and look at the username and password for the PHP noob site. Now, one thing you can do is put them outside the web document room. That at least protects you if there's a misconfiguration and the attacker is able to get directory listings or is able to access these files or in some way. However, that's just a minor mitigation strategy. That file is still going to be readable, especially it's going to be readable by the Apache user. So if they can execute some arbitrary file access, or if they can execute some code as the Apache process, as that Apache user ID, they'll be able to read the connection string.
Aren't there protection against doing things like //// and things like that in files? I thought that was ways of preventing you from doing that.
Absolutely, and that's why. If you place it outside the web document, by default, Apache is not going to let you get to that file. It's that you're going to be taking advantage of some, for example, PHP exploit or some application exploit to be more fair. We've been picking on PHP, but any of the web application languages would be vulnerable.
Like in PHP, would send encoding help at all? That you cannot see some of the configurations? On the PHP side, if you do send encoding,
any type of obfuscation or encoding can be decoded. So it's raising the bar. It's the idea that of those, if you use ROT13 or DES to encrypt the database password, at some point the database password has to be decrypted and put into the connection string, and then you have to store the secret phrase or the secret key to decrypt it, so you have a chain here of events that you still have a secret that you're trying to keep. You have a secret that you're trying to maintain that basically has to exist in a text file, and that's the real difficulty.
So in that exploit that you described, the file, the SQL to write to a file. The SQL is written on the database server, not the Apache app server.
That's correct. So in this case, that's a good point to bring up. In this case, we had a monolithic LAMP environment. So Linux, Apache, MySQL, PHP were all on the same physical host. So in this way, we use the database server or the database instance to write out the file. And because the database and the web server share the same file system, we're able to write to an area where the web server could read it. Now, in other scenarios, the database and web server may be separated. So the file we would be creating would be on the database server, because that's where the actual attack is being affected, rather than the web server. So there's that distinction as well. That's a good point to bring up.
Let's say, if you had to do it, you could use the Zen or VMware on the same box to run MySQL on.
Right, and typically the database contains all the important information about the web application. Usernames, passwords. If it's an e-commerce site, it contains credit cards or data or pricing information. And so the database suddenly becomes very important. So part of that, the good recommendation is that you set the database aside, apply a lot of strict security to that, put the Apache or your web server out front, and the internet's allowed to talk to it. But the only thing allowed to talk to the database is, one port from Apache, one connection from there, and then your back-end administration and monitoring systems. So yeah, we glossed over a little bit of the network architecture, but also as part of that is because network architecture is a little bit agnostic to Linux, Windows, these types of things.
So when you say on a separate machine, you mean like a separate server for the business information and talk to it by strictly filtered SSH access to the user that's very, very limited on the other side?
Right, so you have a secure connection. MySQL supports unencrypted connections. It supports SSL connections between to the database. At that point, you just have a toss-up between performance and security. SSL just has a higher overhead because of the encryption involved in it. But the idea would be your web server talks to the MySQL database. The MySQL database only ever responds. You also block outbound internet connections from the database. And that's the basic, two-step process there.
Based on your experience, do you have a preferred language?
It's a good question. Right now we actually do a lot of development work in PHP. And PHP I'm very familiar with. I think and that's mostly what I've used from a web language. I think that's the question. PHP has a lot of capabilities that allow the programmer to shoot themselves in the foot. So there are a lot of things in PHP that can encourage bad programming practices. But PHP, especially for the 5.0, has object-oriented capabilities. It can be secure, and there's a lot of concepts like input validation that can be written in any language. So. Monitoring. I think what we'll do is we'll leave you with our summary, and then with the time that we have left, we can have Matt go through some of the other attacks, and we can show you a secured installation or a more secure installation of Apache and MySQL and PHP, and we'll demonstrate which of the attacks were blocked, and then which of the ones are still going to succeed, even with all of that host level prevention. And what we really want you to take home this evening is that even simple application vulnerabilities like cross-site scripting or SQL injection, these can be taken over, exploited by simple or very complex attacks. And Matt demonstrated a lot of those. Also, the idea of the application vulnerabilities can target the information of your web server, of your application. You don't always need root. Root doesn't have to be the end game. It could just be, I need to get some tables or some rows out of the database. And finally, even though we go through all the secure configurations possible, at the end of the day, it's an application coding error and a vulnerability in the application code. That's also where it has to be fixed. So turn over to Matt, and you can lead us through some of the through the secured web server, show what works, what doesn't work, and please just keep asking questions.
So we'll just go over here to this this is actually running on the same box. It's a different instance of Apache. It's running a different Apache configuration file. It's running a different PHP INI file. The only thing we haven't changed, we probably don't have time for it, is to go ahead and remove the file permissions from the MySQL user, because it's the same database. So the first thing that I showed was a link that caused a pop-up window in the user's browser. And we'll send that same request again, and now we get this response back from Apache that says method not implemented. And what happened here was mod security was reading all of the data that was coming from the user, and it said, hey, this string, this iframe string here, that matched one of my filters, and I'm supposed to block that. So it said, this is not allowed. And that could be, you could have any sort of message come up there. It could be a 404 error if you wanted. It could be a 500. It could redirect you to another page. Just some behavior that doesn't allow the actual exploit to happen. Or that. That's probably it. You get a lot of fun with mod rewrite and those sorts of sites to stop image leaching. The other one we'll show really quick is the little combo attack there. So before we were able to get a remote shell in the box, but now not so much. So we can actually, let me go back, and we're gonna actually cheat a little bit and pop on the web server here, the demo web server, and let that image wake up. So let me raise this up so you can see it over my document. When running 2 virtual machines on your laptop, make sure you put 2 gig of RAM in.
What CPU is that?
It's I don't know exactly. It's a T60. I don't remember what's in it. It's a dual core processor.
That's what Brad
Yeah,
has.
it's like box CPU intake. I have an odd problem at work. I have a 6700. It's supposed to do hardware virtualization, but when I grab the flags and stuff, proc CPU info, I don't see DMX or SVM.
Could just be In my opinion, a lot of this stuff is supposed to be supported, and then
Could be turned off in the BIOS.
Yeah, but it's not.
so the PHP file that we put on there was in /temp, and it just had that information in there. We'll go ahead and remove it. The reason why I'm removing it is because the payload that I'm sending again is exactly the same, and one of the aspects to that into/out file command with SQL is that it won't overwrite a file that's on the file system. It can only create a new file. So we'll relaunch this attack after I clear out the cookies. Here. Open this up. It's there. Okay, it came back fine. The file's there again. Okay, so we're still able to successfully upload our file with the code in it. However, if I go back and edit this cookie and give it the path to the file, I'm not going to get my shell. In fact, I get a bad request. And this is for a couple of reasons. So first of all, PHP was set, first of all, mod security caught this before we could even let it continue. It looked inside of that cookie value and saw the null terminator at the end of that, that path to /temp/PHP, and it said, no sir. Because that should be coming through in that request. So that stopped it altogether. We got the bad request back. If mod security hadn't been running, we disabled remote file includes within the PHP configuration file. And so it would not have been able to carry out that payload, though the file was still there. So, but we put in limitations to the amount of data that we could send to the server. So if I can't craft a payload, a PHP payload, that's less than 255 characters, or much less because of all the extra data we have to send, then I'm not going to be able to get an exploit up there that's going to be able to do much. So doing just a couple of the things that we showed here can prevent some of these attacks on the server. Just making Apache a little bit more secure, making mod security pick up on a lot of stuff that shouldn't be sent. Ideally, the application developer should be doing a lot of this stuff though too. So.
And at the end of the day, that SQL injection vulnerability that we have is not going to be stopped by anything that we can deploy because it's inside a base64 cookie. And mod security isn't decoding those values and then looking at for attack payloads. It just says, oh, it's in base64, or more realistically, oh, some random numbers and letters, I'll let those through. So SQL injection, so it's just a good way to point out that even though we have all these defenses, there's still a couple that are going to leak through. And that, I think,
there's a few references at the end of the slide. The worm is actually based off of some proof of concept code written by one of the security researcher named Anurag Agarwal, I'm botching his last name. He's out here in the Bay Area, but this was late last year. Some really interesting code. If you want more information on the different if you're like taxonomies and stuff like that, and you want to read up more about web application vulnerabilities, the Web Application Security Consortium's threat classification is pretty good. There's also the OWASP website, which I put up on the slide here. But webappsec.org is a good place to go for a lot of this information. And then the mod security website has the source code for mod security to build into Apache as a DSO. And phpsecurity.net is a good website for information on security about hardening PHP. And the rather colorful and vocal owner of the site is also the guy that was behind the month of PHP bugs that you may have heard about. And that was specifically targeting flaws in the underlying code that makes PHP work. So buffer overflows in the PHP code itself. Stuff that stuff that could be just as damaging as some of the things that we showed you. And then a few other references, of course. MySQL documentation is a good place to start, just to learn how to properly configure it and get your permissions set for users. And definitely do if you run a database and you only kind of run it just because someone asked you to do it. You've installed it, you've given the default login and password, you've set up a login and password for somebody. Go look and see what those users are allowed to do. It's not all, it doesn't say it right there up front in the README. You may be giving them access to write to the file system, or worse. The Apache documentation is lengthy and also extremely useful. There's a lot more things you can do with Apache than what we've shown here, obviously. You may be able to come up with ways to help secure the application just by learning regular expressions and file matching and denying access to certain things. The SE Linux site, you will need a couple of years to go through all of the documentation on SE Linux. Like Mike said, it's very, very, very fine-grained, and it can actually be kind of embarrassing to set up, but if you're really paranoid, it's not a bad way to go. And then the last thing someone had asked about, is there like a guide to follow? The Internet for Internet Security has a lot of really good hardening guides and auditing guides for operating systems and applications. So there's a hardening guide for like Red Hat Enterprise Linux if you run that, FreeBSD, even Windows, Solaris, and even a guide for hardening Apache. Definitely check those things out if you run an Apache web server out there on the net.
What, a MySpace link?